Assalamu alaikum students. Again, in the properties of matter, we have already discussed Pascal principles. Now we are going to discuss pressure in liquids. In that, explain the relation for pressure beneath a liquid surface to depth and to density. That is, pressure is equal to density into height into acceleration due to gravity. Solve word problems on the concept of pressure beneath a liquid to depth and to density. So first we are going to derive a relation for the pressure beneath the liquid surface. For that, let's consider a beaker. This is the beaker. Uh, this is the beaker. Uh, its bottom supports the weight of the fluid. You can see this is filled with the fluid, and the bottom of this supports the weight of the fluid. Let us calculate the pressure on the bottom by the weight of the fluid. That pressure is the weight of the fluid mg divided by the area. Now we know that pressure is equal to force per unit area. In this case, the force is provided by the weight of the liquid, and weight is equal to mg. So we are replacing F is equal to mg by A. Now, to find the mass of the fluid from its volume and density, we know that density is equal to mass per unit volume. So mass is equal to density into volume. So you are going to the volume of the fluid is related to the dimensions of the container. It is volume is equal to area of the base into the perpendicular height, where A is the cross sectional area and H is the depth. Combining the last two equations means that you know that you have done previously. Mass is equal to density into volume, and we know uh, volume is equal to area into height. So mass will be density. Instead of volume, we are writing area into height. Now if we substitute this into the expression for pressure, that is P is equal to F upon A. So that is equal to mg. So instead of m, we are writing density into area into height into acceleration due to gravity upon A. A will cancel out, so we will get pressure in beneath the liquid is equal to H into density into acceleration due to gravity. So if we say on earth the value of G is constant, so pressure then only depends on height and the density, but it depends on the uh, so pressure due to the weight of any fluid of average density at any depth below its surface, for we are which are nearly incompressible. This equation holds for depths. For gases, this is which are quite compressible, we can apply this equation as long as the density changes are small over the depth considered. So this is law is particularly applicable to the liquids. So now applying the formula, a swimming pool of width 9 meters and length is 24 meters. Uh, uh, and length 24 meters is filled with water to a depth of 3 meters. Calculate the pressure on the bottom of pool due to this water. So pressure at the bottom will be calculated by the formula P is equal to density into acceleration due to gravity into height. Now it is filled to the height of 3. So height is given as 3. The value of acceleration due to gravity is 10 meter per second square, and the density of water in SI unit is equal to 1000 kilogram per cubic meter. So we are going to place all the values, and we say that it will be 30,000 Pascal. So the pressure beneath the uh, water at the bottom of this water is 30,000. So again, there one more question. Calculate the pressure exerted by column of water of height 0.8 meter. The density of water is 1000 kilogram per cubic meter. and of kerosene of the same height. Now the height is remain the same, but the density of the kerosene is equal to 800 kilogram per cubic meter. Now we are going to do the solution again. Pressure is equal to height into density into acceleration due to gravity. Height is 0.85, uh, uh, that is acceleration due to gravity is 10, and density of water is 1000. So the pressure for the water at the same height is 88,500 pascals. Now for the same height, the pressure the kerosene oil is exerting is 0.85, that is the same height, but the density is 800 into 10. So this is 6800, that is 6800 pascal. It means more the dense is the fluid, the more pressure it is exerting beneath the at the bottom of that uh, material. So the height and the acceleration due to gravity is same, but in this case density of the both the fluid is not same, hence pressure changes. Those who more density apply more pressure at the bottom, and that is having less density apply lesser pressure at the bottom. So thank you and Allah Hafiz.